This meeting is being recorded.
Excellent. Okay, so it's being recorded. Hopefully everybody who has to click something has clicked something. Now I can see the recording highlighted in the window. Welcome, everyone. Thank you so much for joining us tonight. And thank you, Dr. Berger, for agreeing to be our speaker tonight on IEEE Day. This is very exciting. This series will grow. We have a couple of other speakers who are lined up for the rest of the season, and we will be continuing in the spring and then the summer. So please subscribe. Make sure that you have your chapter or your individual subscription to this so you receive notices of who's going to be live. Please consider this to be an interactive session. The chat window is open. Please ask any questions or raise your hand even during the presentation. It will be really nice to hear from people during the presentation. I'm going to make sure that I have my phone handy, but that it doesn't make as much noise as to interfere with the meeting. It's just I want to make sure I can help people if they're lost or if they need help. So I'd just like to take a few moments to thank everyone who's sponsoring this talk and to remind everybody that if you re-register your membership today, you might get some nice discounts for joining multiple societies and for other very important things that would be helpful to you in your career development or in your experience as a member of IEEE. Can we have the next slide? I think it should have the.
It's now up to Paul. So I'm going to stop the share. So Paul, if you can please share.
Oh, yeah, I thought she went her next slide. Okay. My slide. Yeah, I was waiting for you to turn someone.
Good. No, it's good.
Waiting for someone to turn the page. Okay.
Perfect.
Just a second to get the right file. Here we are.
So a few things about Paul before, as he's getting his slides ready. Notice it's Happy IEEE Day. This is the 15th year they've celebrated IEEE Day, but obviously IEEE, not named IEEE, but IEEE has been around for a long time in some form or another, and Dr. Berger will help us understand a little bit about that during his talk. But Paul Berger is a professor of electrical and computer engineering at Ohio State University and physics by courtesy. He is also a distinguished visiting professor at Tampere University in Finland. He received his BSE in engineering physics and the MSc and PhD in 1990 in electrical engineering, respectively, all from the University of Michigan, Ann Arbor. Yay! Currently, Dr. Berger is actively working on quantum tunneling devices, printable semiconductor devices and circuits for IoT, bioelectronics, novel devices, novel semiconductors, and applied physics. Formerly, he worked at Bell Laboratories, Murray Hill, and taught at the University of Delaware in electrical and computer engineering. Now, this part is going to be challenging for me.
Well, then maybe truncate it there.
In 1999, Professor Berger took a sabbatical leave while working first at the Max Planck. Are you still seeing this recording? Is everything okay?
You're jumping in and out sound-wise.
All right. I'm sorry. I don't know what's going on here. I rebooted my machine before starting this. I hope it's stable. If we have a problem, we'll just come right back to the same channel. But typically this machine is the one that matters, I guess, because everyone is coming through this machine. Okay. And then, in Germany, and then moved on to Cambridge Display Technology, Cambridge, United Kingdom. In 2008, Professor Berger spent an extended sabbatical leave in the Inter-University Microelectronics Center in Leuven, Belgium, while appointed as a visiting professor at the Department of Metallurgy and Materials Engineering at Catholic, is that the way you pronounce it? University in Leuven, Belgium. Professor Berger was also a Finnish distinguished professor, and he continues as a Fulbright Nokia Distinguished Chair in Information and Communications Technologies. He has authored over 240 refereed publications, and presentations with another approximately 100 plenary, keynote, invited talks, 5 book sections, and has been issued 25 patents with 3 more pending from 60 plus disclosures with a Google Scholar Index, H-index of 35. Some notable recognitions for Dr. Berger were the NSF Career Award, a DARPA Ultra Sustained Excellence Award, Lumley Research Awards, a Faculty Diversity Excellence Award, and Outstanding Engineering Educator for the state of Ohio. He has been on the program and advisory committees of numerous conferences, including the IEDM, DRC, ISDRS, EDTM, and IFETC meetings. He will be hosting the IFETC. It looks like 21. That must have passed. Did you do that?
Yeah, this sounds like it's an old bio because my H-index is a lot larger than that.
Tell
So
us
yeah,
what your
this is pretty
what
old.
is your H-index now? I need to know.
40.
Excellent. Okay. So we're going to put this aside and we're going to
Okay.
update whatever is online. Right. And what I would like to just say, because I know you for a while now, and we've had some lovely conversations and have shared a lot of common interests, but I just want to say that Dr. Berger has been a great advocate for undergraduate research, particularly emphasizing the DEAI, diversity, equity, accessibility, and inclusion. That's so important to me and many of us on this call. And that he's been recognized for these achievements, that has a great track record for bringing people through and becoming new PhDs, new master's degrees, people who've gone out and changed the world. He not only talks the talk, he walks the walk, and I can't wait to hear your talk. Thank you.
Thank you so much. So I thought on this IEEE day that this talk would be perhaps pandering to a larger audience that were maybe not so IEEE knowledgeable and so forth. So I start off with sort of a bit of an overview that I just kind of want to place a few emphases here and there just to make sure everyone's on the same page. Again, on this IEEE day of what IEEE has to offer. So I put these 3 logos on the cover page simply because it is IEEE Day. So happy IEEE Day. I skimmed that off of skimmed that off of someone on LinkedIn today. I saw it pass across my feed, so I pilfered it and put it on my slides. I'm predominantly, you'll see here shortly, but I'm predominantly represented in the Electron Device Society, which is one of the founding societies within IEEE. So I'm one of the original core societies. And it's also the 75th anniversary, loosely speaking, of the transistor. And EDS has been kind of celebrating this for 2 years, kind of milking it a little bit, but it is quite a momentous occasion. So I needed to start off with a dad joke here. So I thought this might be appropriate on IEEE Day, just to bring a few smiles or so. But
it definitely lightens the room.
So this is the abstract, and I realized I undercounted. There's actually an 8th council. You may not be fully aware. We got 39 societies and 8 councils, and so this is the laundry list of our IEEE world, right? We've got 39 societies. I'm housed predominantly here in EDS, although I used to be more in the photonics when I was doing more optoelectronics in my Bell Labs days. And then you've seen these councils that have splintered off from some of these societies. Actually, a lot of these came from EDS, like nanotechnology, and I don't know if RFID came from EDS, but Sensors Council, I think, came from EDS, and some of these and so forth, where these don't technically have members directly. You're affiliated with these councils, but you're really a member of one of these 39 societies. So that gives quite a vibrant, rich, ecosystem for IEEE, but that's not all that IEEE offers. And
Is
so
it all right, Dr. Berger, is it all right if I put in a little pitch for the Computer Society right now, since the computer?
certainly, yes. Computer Society is probably one of the largest member-wise.
Absolutely.
Yeah.
And also what we think, I just want to say that, like, even though STEM is so important in terms of like engineering, right? And STEM jobs, Computer Society is like the gateway to STEM for everybody. And like the world is growing, that technology is it's infused in everything. And the less you know about technology in the future, the more on the peripheral you'll be. You won't be in the center. You won't be part of the community, part of the society. Any of these societies will be using computer skills, I'm sure, right? Any of these societies are, yeah,
Mhm.
they're
Yep.
engaging now. Yeah. And especially as you mentioned, that it's the 75th anniversary of the transistor, which changed everything. It changed the potential for all of these things. So I just
Mhm.
want to remind everybody we're part of a big society, this computer society, and that we're bringing these speakers together to help
Yeah,
us understand the whole picture.
you could argue that we're bookends, because when I explained to the uninitiated, my elevator speech, I basically tell them that electron devices were like plankton on the food chain. It's kind of like the very first moving a few atoms around to make some sort of switch. And of course, society is kind of the opposite end of the spectrum there.
Mhm.
Um, so, um, but this is not all what IEEE really houses, right? If you're not familiar, there's IEEE Future Directions. So this has been a new initiative, and I'm involved in the three that are highlighted. Probably a few others at a lesser level, but IEEE Future Directions is maybe still an experiment. It might still be in somewhat of an experimental phase, but it was to create interdisciplinary, multidisciplinary communities, essentially, that were drawing upon those technical societies you just saw, societies and councils. And so, for instance, I'm involved in on the steering committee for IEEE Brain, and I'm a representative for EDS to IEEE Quantum. So obviously IEEE Brain, you could be having signal and image processing, looking at brain waves. You could have something from somebody from the Electron Device Society doing cortical implants, or measuring with a dry electrode system to be able to more easily do a brain scan. A whole multitude of things, right? That you could be doing cortical implants to suppress Parkinson's tremors and things like that. It's just a whole gamut of brain or neuromorphic computing, which kind of tendrils into the computer engineering world, is as how could you compute brain-like, where you're breaking away from the von Neumann architecture and going to, look, our human brain, we can operate all day on a Twinkie, but I dare say our laptops are far from that. Being able to operate and compute more efficiently. So there's a whole menagerie of future directions communities you can get involved in. And if you're renewing your membership, you can join some of these. And I don't even think it really fits in the future directions community per se, is IEEE Smart Village, where they empower the community. And you can see they're trying to bring sustainable electricity, education, and entrepreneurial solutions to empower off-grid communities. I've been involved in this, and in the capacity where I've helped them review proposals and and submitted some proposals of my own that have fueled some of my my humanitarian engineering work overseas. So this is a wonderful entity to get involved in. They're always looking for donations. So if you have some deep pockets and you want to donate, this is a very worthy cause. I think IEEE does works very efficiently.
Can I ask you a question, Dr.
Yes.
Berger? Okay, so some of us get involved with humanitarian activities because it gives us a possibility of doing good things with our great, cool engineering skills that we don't always get a chance to do in our everyday life.
Hmm.
But then it becomes sort of like a really a very happy place to go with your skills, you know, doing these humanitarian things. Can you tell us how you became involved and when it happened for you that you really decided this was a really way cool thing to do?
It happened by accident, to be honest. Um, I had actually, can I hold that answer because the answer will make more sense after I get a little deeper in this.
Sure.
Okay, okay. Um, and then if you're, you know, I think most of the people we're talking to here are from North America, but if you're not, welcome. We're all everybody's welcome. But you know, IEEE kind of its epicenter kind of started out of the Americas, and so it was the United States was carved into these six regions here, and what's happening is, of course, there's been a realignment, and so Region 1 and Region 2. I'm a part of Region 2 here, just below Michigan here in Ohio, and we're being merged with Region 1, which is opening up the opportunity that Asia is going to be Region 10, which is Region 10, is going to be parsed into two areas. There's going to be sort of the mainland Asia, and then there's going to be the Oceania, you know, sort of Australia, New Zealand kind of ecosystem. Um, and so this is all the different regions. So I've been participating in Region 2 activities as well. So segueing into that. So I was drawn in to be vice chair actually for IEEE Columbus. I've been was elected. We ended up really transforming and kind of resurrecting the Columbus chapter section. It had kind of fallen a little bit dormant, and so Helen, under Helen's leadership, and I was basically riding shotgun with her. We were able to elevate that and became the outstanding medium-sized section in the world in 2022. So that was our second year as my second year as vice chair of this new team. And so we were most of us except Howard were reelected. So I'm actually winding down my second term, and we're trying to decide who we can transfer leadership to. So these different um, uh, you know, these different areas represent different, there's different sections. So within Region 2, you can see how it's carved up. These are not counties or states, right? These are different sections. So the Columbus section straddles from Columbus, which is the bullseye center of Ohio, and it goes all the way down to where Ohio University is in Athens, and sort of that strata. So it's kind of a section from the central to the southeast section of Ohio. And that's where the Columbus section is housed. And there's many other sections within that. So this is another way you could get involved. So if you're not in the technical side, you can work with your community, fostering the local section. They're always short on man and woman power. So I highly advocate getting involved and helping. You can see how it's enhancing it. You know, you're basically the section acts as the central framework, and under which student branches are being serviced and mentored, as well as local technical chapters. So if you're a technical chapter, in any one of those 39 societies or 8 councils. You could easily have, if you have, I think it's a petition of 12 people, you could have a local chapter in your community, and so that's easily an opportunity. I was the faculty advisor for our IEEE undergraduate student chapter for many, many years. And in fact, we hosted on 2 occasions. Here's my team. These are my my officers and officer team. And we ran the Student Activities Conference for Region 2 twice. You can see here, last time was 2015. It's been a few years since I handed over the reins of this, but back then we were hyperactive during my stewardship of that. And in fact, that became so vibrant that, to be honest, the graduate students got jealous. And because the graduate students have a completely different need than undergraduates. So we ended up having a petition to IEEE to create a graduate student body only. So they call themselves GSB, Graduate Student Body. And so it turns out that we were the first graduate student only chapter in the world. And it started here in Columbus. And one of my officers from undergraduate tried to recruit him for a PhD, and he took an offer down at Texas at Austin and Sanjay Banerjee's group. And so when he was down there, he actually created an IEEE GSB as well there. So apparently there's at least 2 of these GSBs hanging around, and certainly other communities are welcome to add that. Kit was, again, in the introduction said that I was the Educator of the Year for the state of Ohio by the professional engineers. So that's not your IEEE world. I actually won in 2023 Outstanding Educator of the Year for Region 2. So that's like, West Virginia, Virginia, Maryland, Delaware, parts of Pennsylvania, Ohio, and so forth. So this is quite an even larger area. So you can get involved in your community, all these things, working with students and so forth. And then, so then that helps me answer Kit's question. If I want to circle back to that, she asked me, how did I get involved in the humanitarian work? And if I have time some later, I have another PowerPoint presentation I could pull up. I may not have that much time, but essentially there was a student club. So I was running these 2 student clubs at the time, and I actually created a 3rd one for the underrepresented engineering students in electrical engineering. So I called that RISE. I'm not showing that here because it's not specific to IEEE, but I was actually running 3 student clubs, and there was a club on campus called Solar Education and Outreach that had done a solar decathlon years ago. I don't have time to explain that right now, but it's run by the Department of Energy, and that from the energy that created on campus, they created this club, and then somehow that club started going to Haiti and doing an alternative spring break, essentially. And their faculty advisor was very kind of asleep at the wheel, and it was not non-performative. And so the students kind of learned of my reputation working with students, and they reached out to me to be their new faculty advisor. So being the faculty advisor for Solar Education Outreach led me down this pathway. I started mentoring the solar service learning projects going on in Haiti. Essentially, they were putting up solar panels on remote schools in Haiti. And then, as you probably know and follow the news, Haiti became unsafe. So long before the presidential assassination, my university said, you're not allowed to go there anymore. And so that led to, we were rudderless, we were without a country for 3 years, and eventually I reemerged with two other service learning projects, one in Colombia, South America, and another one in Tanzania. Tanzania eventually got also canceled because of COVID, and I'm actually rebooting this year, coming up in May 2025. I'll be doing a fourth one in the Navajo Nation in Arizona is the plan there. And that solar education outreach, by the way, this little kind of handmade cup, they actually won the Solar District Cup a few years back from the Department of Energy, where they designed whole solar power systems in the greater Denver metro area. So I wanted to get a little bit. So one of the things that Kit had baited me on, the original inspiration of this, before we moved this to IEEE Day, which is why I gave all that introduction, was semiconductors. Kind of what is a job in the semiconductor arena? And I just kind of want to point out that in semiconductors we have quite a large variety. I mean, it's bringing in material science, electrical engineering, physics, chemistry, mechanical engineering, and you could probably even say in some modalities, biomedical engineering. And I may have even forgotten some, certainly mathematics, of course, but I always argue mathematics is simply the language of engineering, language of science. And so this really brings in many, and that's one of the things I like in the semiconductors is that it's bringing in all these different aspects. As an engineer, technically as an engineering physicist, as my bachelor's, I was exposed to all of these and took core mechanical engineering classes and material science classes and so forth. And I still leverage a lot of that to this day. So I found it very revealing. So you probably know the semiconductors, right? We have the Intel wafer and a FinFET, where it's got the gate wrapper all around, and you've probably seen from the Computer Engineering Society, you've seen things where but by the way, I don't know if you know, but this this is a scanning electron microscope, which is like this, supposed to be black and white. So someone has artistically photoshopped this to make it look copper-like. That's not the way it comes off the presses when you run a scanning electron microscope. But the other thing is basically they ruined this wafer. I don't know if you realize this, but they basically dipped this in acid and etched away all the insulation, all the interlayers, and leaving the copper interconnects here. So basically this is a ruined wafer, but it's very illustrative because it shows you all the highways and byways of how the signals are routed around a chip. And so, of course, a microprocessor might look something like this, where you got the pinouts and the wire bonding, and then you seal it up ceramically, right? So you got a lot of disciplines: material science, chemistry, how to etch this is chemistry, how to do the deposition is chemistry, and so forth. And then, I'm sure that from the computer engineering demographic, you full well know Moore's law and marching through the different nodes and so forth. Now, this is pilfered from Intel, so it's Intel specific, but this is happening across the whole industry. And you can see how we're basically right around here in this time frame. And so you could think of Moore's law. This is pilfered also from Applied Materials about some of this going from FinFET. What's after FinFET? Well, it looks like it's going to be more like the gate all around topology rather than a 3-5 FinFET or a vertical tunneling FET kind of template. So I think this is starting to be the workhorse that's being leveraged. But there was a time when people didn't know where the fork in the road was going to take us. So as we're marching through Moore's law, right, we have the doubling of the chip density and so forth. And so as we're going through that, what you may not know, and this also comes, I think, originally from the Computer Engineering Society, is we have the ITRS, which later became the IRDS. And so if you're not familiar with this, let me just kind of briefly explain. So the ITRS was a way to do road mapping activities for the semiconductor industry. And so as you're going from node to node, does it let me go backwards here? Oops. Okay. Yeah. As you're going from this node, 10 nanometer to 7 nanometer to 4 nanometer, that's quite a Herculean effort. So I have an Intel factory that's being built like 25 minutes from my house here in central Ohio. And so when they're building this factory, they have to know what is coming into that node, that next node that's going to be populated there. So that's going to cost, I think you've seen in the news, that's going to cost, $2 billion or something like that, which is not just laying around, um, under the mattress or anything like that. So when Intel or any other like-minded company puts down such a breathtaking large amount of money to build a chip fab plant, that means that chip fab plant needs to be producing wafers 3 shifts a day, 7 days a week, once it's functional. And in order to have this ballet of going every 2-3 years, jumping node, recognize everyone focuses on the blue. The semiconductor manufacturers, the Intels, the TSMCs of the world. But recognize one of the road mapping activities is to calibrate, because Intel may be building the factory, but Intel will be populating that with nanofab tools, doing lithography, ASML and etch and deposition and a whole multitude of different tools. So those tool manufacturers need to know through the road mapping activities what is the new line width dimension, what is the new specification needed for that next generation, so that when they're doing their development, and Intel is doing its development, the tool manufacturers have a tool that's able to meet those new specifications. And then that's also not in a vacuum. The chemicals, the gases, the resists, the metals, the wafers, they might need to be flatter, cleaner, less contamination, or shifting to a new precursor gas or a new resist or so forth. So essentially, these 3 cogs in the system are all having to work together, and having that road mapping activity calibrates them all so they all converge at the same point in time, so that when that new node launches, they're all ready to launch together. So the ITRS, which was more semiconductor related, then shifted to the new name, International Roadmap for Devices and Systems, recognizing that devices and systems go hand in hand. It's a push and a pull. So the devices are not done in a vacuum. It's the system pulls requirements that the system needs a better device, or the devices have an improved performance, which enable a new system, right? It kind of goes back and forth depending upon the innovation. But devices and systems are really 2 sides of the coin. And so the new name is the IRDS, and that's out of the that's predominantly run out of the IEEE Computer Society. I know EDS has representation there, but it's run out of the Computer Society. So the whole semiconductor industry, is vibrant, right? It's over it's over 500 billion, over half a trillion. You can recognize the name. There's names. There's the companies that make the wafers. There's the companies that design the wafers. There's foundries, non-foundries, etc. All these, and so everyone fixates on these kind of companies, these kind of electronics. And one of the things I want to kind of point out to everyone is this is not the only game in town, right? There's other relationships to semiconductors, so bear with me on this. So these are sort of your main semiconductor vendors, right? Intel's, this is the 2022 rank, 2023. You can see a lot of companies took a bit of a hit over the years. And so if you think about this whole market, this number kind of came up with a slightly different number than the previous slide. They were saying 533 billion, so close. Depends, I guess, how you're counting. Now, a long time ago, a personal friend of mine, Egbert Volk from University of Michigan, he was kind of one of the things I was trying to discern from all these um, uh, 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 tables and all of this is what's the relationship between the silicon industry, the compound semiconductor industry, and of the compound semiconductor, what is the say LED market? So these are inorganic LEDs. So this is kind of before OLEDs really took off. And so at the time, he was pointing out that all these silicon companies that we focus on are really 91% of the market, at least 9% or more. It's probably grown a bit, are the compound semiconductors. So that's the gallium arsenides, the indium phosphides, and so forth. And then a subslice of the compound semiconductors is the optoelectronics, say lasers and LEDs and things like that. So there's much more than just an Intel factory. There's the gallium arsenide MMIC. There's the there's just a whole multitude, gallium nitride LEDs and so forth. So you can see tracking the semiconductor unit growth has just gone up and up and up. It had fallen back a bit in this last year. I think one of these slides shows that that one of these fell back. You can see TSMC in this one out of Taiwan is leading in 2023, and you can see some of these are foundries, some of these are fabless, and some of them do everything from soup to nuts, like Intel and Samsung. And so you can see, if you're being a little bit dismayed in the semiconductor industry, I just kind of want to point out, and you can see this in this slide here, the semiconductor market fluctuates very wildly, very wildly. You can see as each node is coming on and off and so forth. Sometimes you can see a 12% degradation in the sales, 5% more closely here in 2023. So some years are just flying high, 25% growth, and others, 12% negative growth. And so that's what we see right now. We're hearing stories. There was a story about a month ago here in Central Ohio talking about, with Intel and its certain situations, business-wise, how are they slowing down in the building this factory here in Ohio? Time will tell. In fact, there was even some pundits that were kind of worried that they might never finish the factory and so forth. So you can see how these market fluctuations can really cause a lot of heartburn, I think, for those for leadership in these companies. This is some of the thing. The thing is, what I find solace here is that although it may slam down very, very abruptly, it also can pick up in the same heartbeat, a heartbeat later. So although things are looking a little bit grimacing and dire now, I think they will be picking up. So I think it is something to continue. Then don't forget displays, right? Displays utilize a bountiful amount of semiconductors. And so obviously you're all looking at this presentation through your own displays. And that could be a liquid crystal display, or it's probably not an e-ink display to do video, but or an OLED display if you're using a phone or so forth. And that's a sizable chunk of the market as well. So in addition to the 500 plus billion of semiconductors, you have the display market, 100, let's round it up to 170, growing to say 260 by 2035. So that's a healthy growth as well. So you could be making displays, e-ink displays, for instance. I don't know if you've seen, I've got an e-reader using the Remarkable 2. If you've seen that, it's a very nice unit to allow me to read PDFs and proofread papers and things. E-ink that now actually came out with a colorized version, so I'm kind of kicking myself. So you can get a colorized e-ink display now. It's just hitting the market. So displays are just taking off, and you're needing transistors to drive each pixel. So smartphones, right? You know, they're really kind of predominantly talking about OLEDs, which I worked on in the early days back in 1999 in Europe. That's just taken off. You can see how it's mostly over in Samsung. They're the behemoth here that owns most of the smartphone display technology here, but also BOE and LG. And you can see how this is, and it's got some market fluctuations too. You can see the growth sometimes up, sometimes down. So worldwide smartphone shipments actually fell in 2023. So we'll see how that goes. Maybe people are finding their smartphones are good enough. I don't know. Or maybe they're moving to tablets. Who knows? And then so the display market you can see is just, you know, quite large. It's 31% of global market revenue was accounted for in North America alone. It's based on display technology like OLED. It's going to be growing at 4%. So, you know, it's going to be quite impressive going forward. So that's also lots of job opportunities. Flexible displays, probably a much smaller portion of the market, 13 billion. But you know, we have foldable phones. This is part of the area that I work on. Flexible displays are going to be taking off. You can see it's growing gangbusters here, 33% over these 7 years. So it's expected to go up and up and up. So here's kind of the flexible printed electronics and mobility, being able to do the foldable phones and all that. I think they're starting to work some of the bugs out. And don't forget RFIDs, right? If we're doing a product inventory and so forth, you know, you probably have bought a piece of clothing or something like that with this tagged on it, or some high-end, you know, I just bought some replacement razors, and it seemed like some of the razors in the CVS display had some of these, you know, RFID tags to keep shoplifters. But this is expected to grow and grow and grow. In our area, the area that I represent now, flexible printed electronics, this is really taking off. Companies like Pragmatic, if you're familiar with them, out of the United Kingdom, they're basically using older generation CMOS equipment that has been starting to be abandoned, and so they repurpose it for flexible printed electronics, and they essentially use a 200 millimeter carrier wafer, and then they put down a polyimide base coating, and then they build some IGZO thin film transistor technology on top of that. And they're actually in the process of following sort of a Moore's law progression in the chip density themselves. And then at the end, they peel that off the silicon wafer, and they actually have flexible printed electronics. And that's easily now and it's 2 days. Catherine Remsdal was just at the conference I was at, giving a plenary talk in a flexible printed electronics conference in Bologna, Italy. And she said that basically, unlike an Intel process flow, it's really 48 hours from beginning to end to the process flow for their electronics. And so they see RFIDs clearly as a future opportunity for tagging inventory and so forth. So I had a former student who's now a professor at Rochester Institute of Technology, and he's got some slides that I was going to maybe go into next, but I want to pause before I go any deeper into this. How about any questions? And how am I doing on time also? Oh, I'm
I
getting
have
near
a
the end.
question. If no one else has a question that's
Yes,
urgent.
yes.
Yeah, okay. So my question is, what about the recycling or the life cycle of these products? Is that feeding into the variability of demand? Like, are we facing our ecological sustainable development goals in this field? Do we have some markers or uh,
This
missions
is
that?
so my European team is very we're very well represented. I see this very predominant in Europe, of carbon neutral and so forth. So, for instance, one of the projects we have funded in my Tampere, Finland team is literally the acronym of the project is called SOIL, and it's actually targeting being able to do printed flexible electronics for intelligent agriculture. So being able to monitor crops in real time, pH, humidity, moisture, sugar content, a whole multitude of things, where the electronics is not only biodegradable, but it's actually environmentally friendly to the crops. In a way where you almost think of it as fertilizer. Let's say your soil's a little deficient in manganese. Well, how could we make printed flexible electronics that's leveraging the usage of manganese? So as we put these embedded sensor networks in the field, um, so I don't know if you've seen today's agriculture is really becoming high tech. I mean, they're essentially digitally printing fields because there's microclimates in every part of the field. There's a little bit of a dip, a little bit of a valley, or a little bit of a hill. The way the water flows when the rain comes down maybe causes the bottom to be a little more nutrient rich and the top of the hill being a little bit nutrient poor. And so being able to properly dispense fertilizer and other nutrients where you're not just flooding the field with more causing algae blooms down the way a piece. So yes, having flexible, and that's another advocation for pragmatic as well, is that they're much less, their carbon footprint is much lower than, say, an Intel-like process flow. And so not everything, so one of the things we advocate is not every solution has to be silicon. There's a lot of things where it's simpler embedded sensor networks where it could be printed flexible electronics to be able to monitor.
Are you able, in your soil program, are you able to get to monitor the surface of like I understand there's a loss of topsoil over time. Are you able to measure that and perhaps predict
um,
what might be contributing?
that's not really in our field of electrical engineering. That's maybe a little more agricultural, but yeah, I think because that gets into things like cover crops when you're not and all kinds of things. That's a little bit outside what we're doing, but we're trying to help empower them so they can see what they have, they can measure what they have, so they can see that in real time. So
Excellent. Very cool.
yeah.
Anybody else have a question? Has anybody been interested in this particular field of agriculture? Are there any other general questions that we could pose to our illustrious speaker today?
I could also share with you. Let me hit stop share. I'll just give you a little bit of eye candy for the where is it? Here. This is the um, humanitarian that she was asking about earlier.
Excellent. Yeah, because sometimes people wonder, what is this humanitarian thing? I'm busy at my job. Why would I want to do this? And sometimes I think one of the opportunities you have when you're doing humanitarian, you get to exercise engineering skills outside of this, whatever the domain is that you're working in,
Yeah,
and learn from
yeah.
other people.
Yeah.
And also appreciate the bigger picture, meet people that you may want to work with in the future, maybe even choose a different area of engineering you might want to go into.
Yeah.
But in fact, you're really helping people. So
Yeah.
there's all of that. There's many layers to this.
So these are the 4 areas that I've been involved with. And so obviously the if you're not familiar with the United Nations Sustainable Development Goals, you should be. There's quite a number of them. These are the ones that I kind of map onto. And these are measurable, actually. If you go to this webpage, they're actually seeing how each community, each country is improving, say, in clean water and sanitation over the years. Sometimes the data is very dated. It's a little slow to be updated, but you can see this progressing, how the world is progressing. So this is the solar decathlon where they're building these sustainable homes, and that happened in 2009. And Ohio State was a finalist there. They actually have a Wikipedia page that talks about this. Yeah, here it is. Um, and and this team was so empowered by all that, they came back and formed the Solar Education Outreach Club, and they started going to Haiti, and I became the faculty advisor in between here. And this is the kind of stuff they were doing. They were doing solar panels for these remote schools. And I remember one of the hurricanes blew through Haiti, and they contacted the community where they put these solar panels up. And it turns out the whole roof had blown off except where the solar panels were, because my students had reinforced the roof to hold the weight of the solar panels. So the solar panels were on more securely. So the rest of the roof was gone except where the solar panels were. So I got a kick out of that. But then Haiti became unsafe, and we switched from quarters to semesters, which made it kind of awkward. And so basically, OSU curtailed operations. And so then, where in the world to go? We were without a country for 3 years. And I was originally looking for kind of somewhere in the circle. I was looking for some place that we could fly from Ohio and get there and back in a week. And you can't really, in fact, probably even this is too far. So I was focusing on that. But when we went to semesters, that allowed us to use May. May became a Maymester. It doesn't belong to spring and it doesn't belong to summer. Engineers, it's just 4 weeks of, and it fostered these service learning projects. And so service learning is not just students, outgoing students going into the community, because I'm really a big advocate that we're not just parachuting in privilege, taking some selfies and leaving. I don't want to see all this stuff on their Facebook, social media feeds. What I want is our students work with local stakeholders, and then I also try to build a triangle where they're working with a local university. So what I'm trying to do is have our students work with local students of the same age so that I can foster a one-on-one relationship. Here's the project we used to do in Haiti. Here's the project I'm doing in Colombia. Here's the project we did in, pre-COVID in Tanzania, and this is the new one that I'll be initiating in 2025.
Congratulations on that one. That's going to be marvelous. It'll be.
We're getting low on time. I'll just give you a
Mhm.
few. This is Tanzania. Yeah, we were in an orphanage, and so this is the team. A lot of people actually were really, I mean, we had environmental and natural resources. Some of these, people barely had algebra. And so we basically in the field taught them Ohm's law, and from there we taught them electrical engineering and how to do wiring. And so they learned what a solar power system was. They designed a solar power system, they built the solar power system, and they installed the power system all in 10 working business days. So, all these guys. And so that's the orphanage where we did, and these are this is what the graffiti they have. So you can see these young students are actually learning about neurons and condensation and evaporate. I mean, it's really they're quite progressed. And so we ended up putting in multiple we put in a multiple circuit, like seven different circuits, I think. We had an area where they take showers, where they brush their teeth, where they change their clothes. There's the area where the younger children sleep, and then the older children sleep. Those are partitioned. And we had to put everything in PVC piping because we didn't want the little young boys jumping up and down on their cot bed, their double bunk beds and getting electrocuted. So everything was housed in PVC piping. So this is the construction. We had to put the batteries inside. We had this designed and welded by a female-owned welding business there in Tanzania. So basically, these kids, did a great job, surrounded by volcanoes, and they blessed us with Maasai warrior blankets. That's my resident director, Turner. These are the kind of things we did. That's the completion. And then we did, here's the project I'm working on now. It's down in Colombia, South America. This is the desert community where it's salt everywhere. These are the indigenous Wayuu peoples. And this is their community. There's a high incidence of asthma in children and elderly because the water quality is so poor. And yeah, this is the water quality. This is what they're drinking. This is an above ground swimming pool with this algae growing on it, poor, salty, contaminated, limited solar. So what we're trying to do is jump past this. I also got stuck in South America for 4 months when the pandemic was declared. So I actually finally escaped with my life after 4 months. I came back with COVID. But let's talk more about this. We took this donated shipping container and cut it in half and put ventilation in and derusted it and repaired it, put a dedicated trailer, and inside we're putting the batteries and the water filtration, and then we have solar panels on the outside that fold up like an umbrella, these kind of things. This is Navajo Nation, where we're going next. Also very desolate, arid-like, water quality, very poor. We were working with Nicole. She's quite a mover and shaker in the Navajo community, the Dene community. They prefer to be called Dene. And this is her NGO working on water rights and so forth. So some of the things we were thinking of doing is like a hoop house where we could use solar panels to energize this, because this is one of the farmers. Actually, this is his hand. You can see he actually left the doors open when he went into town because it's 2 hours to get into town to do an errand to get some drinking water, and he left the doors open, and all his crops, most of his crops died. You can see how hardly anything's left. And so we wanted to, one of our aims is potentially use solar panels to electrify this so we can open and close the doors and windows so we can regulate the temperature. But I'm currently, we're running a little bit out of time. Let's ask more questions and see how you're doing.
Wei Fang, I see that you are very interested in this, I noticed, and I hope you might have a question for Dr. Berger.
Yes, yeah, I do have some questions. So I would want to know that. So could you talk about a little more about, like, for example, the solar water project, and this is mostly like that is a variable project. And do you collect the data from this and do some analysis, or how you make this data work?
Well, we've not gone to Arizona yet, and this project in Colombia has still been somewhat problematic. It hasn't quite finished. Some of the key units got destroyed during COVID, and so we've been replacing them and slowly working the bugs out of that system. It's not quite operational. We've not delivered it to the team yet. But one of the things we were hoping to do is because you can see this is 2019, We were
Mhm.
not allowed to return in 2020. One of the ideas was if we went back and we did a second solar project in Tanzania, we were going to revisit the old project and see if we could put this add some extra circuitry so that we could take the data and put that up to 4G network, and then we could build a web page here in Ohio, and we can monitor the ups and downs of the solar system and see how that correlates to the weather patterns and so forth, and its robustness and its efficaciousness. Are the batteries degrading and so forth, and being able to do remote monitoring. And then here I could use it as a teaching
Oh, yeah.
opportunity, especially when we go and do outreach from grades. Sometimes we're doing outreach grades 5 through 12 in the community, and so being able to pull up a web page and say, "Hey, this is something we built in Tanzania," and watch the solar, the solar energy go up and down as the days go up and down. So yeah, I would like to be able to do a lot of that.
This is fantastic. Yeah, yeah, very impressive, the presentation. Thank you. And yeah, since you can monitor the data, like we can do the real-time analysis. You know that as an AI people that we always interested in this in real-time the data analysis. So that would be fantastic if this right. You can monitor this and collect this data, and so some people can use this data to do some analysis, similar as the video analysis or the real-time or the dynamic data analysis.
Even if you have some sensors in the field somewhere, we could look and compare satellite data with the sensor data that you have and try to see how accurate the satellite data comes in compared to what's going on in the field, and so not just even if you didn't get your whole system up and running as you wished, there's still an opportunity to do some really great research to figure out what might be needed and how to compare it to other places where you might want to do some project. Bobby asks,
I'm going to bait you with one last thing.
Okay.
Is that so of those technical societies and councils, you can get into IEEE publishing. So I'm the founder and editor-in-chief of the IEEE Journal on Flexible Electronics. And these are some of the special issues. And I'm particularly proud of the one on the left because this was a special issue on flexible electronics for emerging markets and developing countries. And you can see how we're using printed medical wearables like a electronic tattoo to be able to monitor patient health and digestive health and heartbeat, water. So think of this Fitbit being replaced with a temporary tattoo that costs just pennies to print, or it's monitoring your brain waves or stuff like that. So you can see all these different kind of applications for flexible electronics. So I'm really excited about being the editor-in-chief of this and the progress it's been making.
And the appeal for people in AI and machine learning is very cool, right?
Yes. Yeah. Yeah.
So one of the questions, in the Kansas City area, so we can look. Yes, the site groups. There might be a site group in your area, and if not, you can start a site group. But also, you can get involved with site and see if any of them has a project in a region or a topic that interests you, and get involved with them. Dr. Berger, have you done such a thing? Have you looked around at some of the other site groups to see what they're doing and joined another group other than you were involved with?
Yeah, actually, this last slide here. Let me pull this up.
So we have a site group here in our chat section.
So what she's talking about, if you're not familiar with this is the last slide in my humanitarian slide deck. There are 3 different funding modalities within IEEE. You can get a special interest group called SITE, and that is between 1,000 and 20,000. I was loosely involved in one here in Columbus during COVID that was supposed to bring a hydroponics garden to a food desert community in the urban Columbus area. That did kind of fall apart, but that was something I was loosely involved in. The project down in Colombia, South America, was funded by the Humanitarian Activities Committee, and that you can usually request between 20,000 and 60,000 US dollars. And then if you really want to go big, when the Smart Village is disseminating money, as long as you show sustainability, that the project that you're building is can self-sustain itself, is what I mean. Not sustainable in the sense that it's carbon neutral and all that, but obviously we want it to be maybe a solar perhaps, but that it can self-support itself financially in years 2, 3, 4, and 5. Especially things like off-grid community, empowering off-grid communities. That is really large money potentially. So you got the baby bear, mama bear, papa bear of the IEEE world for humanitarian funding. So I hope that helps.
And it turns out that many of the technical societies have their own flavor of humanitarian technology or humanitarian projects, like Antenna Propagation Society has COPE, which is another group. So if you are a member of another technical society, you can perhaps look at their website and get some ideas about what kind of humanitarian projects they're interested in fostering as well. Anyone else? David Bondurant, do you have a couple words for us?
I just was asking about organic ID. I'm in Colorado Springs, and so the company called Organic ID was founded here in Colorado Springs back in the 90s. And they ultimately were sold to Weyerhaeuser, and they demonstrated a RFID, basically a UPC RFID back in the 90s. I just was,
I'm not as familiar with the organic ID. I know that there were some that fostered. So the RFID killer application took a long time. It actually they tripped on themselves, and for whatever reason, the community, what they were able to produce back then wasn't good enough, and it fell vastly short of expectations for RFID, and so it basically got a very bad reputation, and it's only just now kind of re-emerging as this opportunity and possibility out there. The older stuff so I've seen Pragmatic is actually working with Avery Dennison, and probably most people on this call don't know Avery Dennison. I've kind of learned of them. They are the largest manufacturer in the world of sticky labels. So you go to a conference or an IEEE meeting and you get one of those name tags. It's probably Avery Dennison or something like that. So they make sticky labels. So they've been working with putting printed electronics and adding RFID functionality to their sticky labels. So then this is going into products all over as a potential where maybe we could dispense with those UPC symbols, where you pick up a box of cornflakes and you got to find for the barcode to be able to scan it with the lasers, the laser scanner at the grocery store. Well, here you can just wave a wand and ping your grocery cart, and it'll tally your entire bill. Amazon says they're doing this now, but they use a multitude of cameras, and they're using this computer vision essentially to ascertain what you're putting in your basket. They're not actually measuring it from first principles like an RFID.
Interesting. Tom, does this remind you of the shelf tag? What do you think?
Well, yeah, I do remember the shelf tag project back in the 90s. Hey, Professor Berger, I wanted to really commend you for all your support of the United Nations Sustainable Goals in all these various communities. I think that's great work you're doing. I did have a question. Do you find that it's possible, easy, or difficult to train the local people in those communities how to run these systems. So like, once the IEEE people, leave and go back to their universities or whatever, it's left in the hands of the people in that community to keep it running. Are they able to do that easily? Do they need, routine or
That's why I'm
periodic
an
support?
advocate of a triangle. Because if I had a robust triangle built, then we would have worked with the local Arusha Technical College students, who then they would be more cognizant of science and engineering and so forth, and they could go over the orphanage because it's 5 miles away, and they could go check on the system, and if something a weld popped, some wire delaminated in a rainstorm, they could go over and resolder it back together again. So obviously we can't go from Ohio just to go over and do a house call visit. So building that triangle and having both local community stakeholders and a local higher education institution, I think not only gives a more robust relationship to my students going overseas, but now the community is able to be more self-sufficient.
That sounds great. Thanks again for all your work.
You're welcome.
Well, I think this has been a fantastic way to spend IEEE Day, to hear about technology and also about the humanitarian part, and to dream and envision that we can all be part of this changing world to make good things happen every day. I'd like to thank everyone who's been here. If anyone else would like to say something, please feel welcome to speak in this room. And otherwise, I would like to just say good evening, and I will turn off the recording now.